All right, so let's learn how to calculate a very rough exponential model to kind of see where this is coming from. And we'll see that this is a simplified model, and we'll look at some actual data towards the end. So the idea is, if I say on Monday of spring break there were 14 cases of coronavirus in Maine, by Friday there were 52, it's traditional to take the first day as day equals zero, day zero. And so counting from Monday, day 0, Friday is day 4. And so what we want to find is the exponential rate, the growth factor, sorry. And so we're going to calculate something we'll call a to the power of b. A is this fraction. It's how many infections do we have now divided by how many infections did we have then. So 52 over 14 is 3.7 blah, blah, blah. And then B is a little funny. It's 1 over how many days have passed. Well, day 4 minus day 0 is 4. So it's been 4 days. So it's 1 over 4. That's 0.25. So we take a to the power of 0.25. People tend to make some mistakes here if you're not careful with your calculator. So I'll include a lot of notes on the top hat questions. So we get this number, 1.38, blah, blah, blah. This is R. This is the growth factor. And so our exponential equation is going to start out with the number on day 0 times R to the power of t. R is our growth factor. Let's see how this works out. We can interpret R is 1.388, etc. as we can say a couple things. We can say each day there's 138.8% of what there was the day before, which is the same as saying there's a 38.8% increase. So anything over 1 is the increase. You can turn it into a percent by multiplying by 100. So based on those two data points, and assuming exponential growth, and there's good reason to believe that, we'll see in a couple slides, that would be a 38% growth rate, growth factor. So exponential growth is not always just doubling or tripling. It could be a 1% growth factor. That could be exponential growth. So let's, there's been a lot of talk about doubling, that one person affects 2 people, or one person affects 2.5 people, or what have you. So there's a couple things that muddy the waters there. One, it depends on geography, right? More densely populated areas will have a faster spread of disease. It depends on what the society is doing. As I'm sure you're well aware, many of us are working from home, we're going to school from home, we're socially isolating, lots of things have been canceled, gyms are closed, movie theaters are closed. So those things will impede the spread of the virus as well. And testing. We only know of cases if we test for them. And different countries have different testing responses. And if we're not testing a lot of people, we don't really know how many people are infected. So that affects our knowledge as well. In any case, so we have this calculation. I think you have access to the slides, so you can go back and look at the slides one by one. And the interpretation is a 38.8% increase each day. And our equation is 14 times 1.388 to the t. T is our power. So we can predict with this, right? If I want to know what's going to happen on the Friday, what day is today? Today is the 24th, so 27th, right? That would be 7 days after last Friday. So that would be, oops, I didn't fix the little typo there. Oops. So it should be 11. So I put 11 in for time. I get 515 cases. So that's the scary thing about this, is that the Monday of spring break, we have 14, and quite likely by the end of the first week of classes after break, we could have somewhere in the vicinity of 500 cases. It changes rapidly. And that might still seem small to you, but remember, as hospitals are dealing with things, they're still dealing with flus and pneumonias and broken legs and cardiac problems and all those things. Those are still ongoing. So if in the course of 2 weeks you end up with 500 additional sick people, that can overwhelm a hospital. Hospitals aren't in the business of having lots of empty beds. They're expensive. So this is part of the fear, is that we're worried about a sudden increase that overwhelms medical infrastructure. So let's look at another prediction. So this is 2 weeks out. So the 4 represents the Friday of spring break. So this would be 2 weeks out. We're into April now, and we could have 5,000 cases. Now, of course, not all of these require hospitalization and so on and so forth. We'll get into those numbers in future lessons. The idea is that this happens quickly. Exponential growth happens quickly. And if you're not careful, if we're not doing all the social distancing and isolation and whatever, these 5,000 cases can infect more. Let's take a look at this. So suppose instead of 1.38, we have 1.28. So instead of a 38% increase, we have a 28% increase. And let's compare those two predictions. So we had just computed that first Friday in April, possibly having 5,000 cases. But if we enact stricter measures on how we're associating with people, we're washing our hands, we're staying 6 feet or more away from people, suppose that lowers this R value. And that's the whole point of these measures, is we're trying to alter the growth factor. Well, then we have maybe 1,300 cases by the first Friday in April, as opposed to 5,000. So these are small numerical differences that could result in, 3,800 less people seeking medical attention, taking up swabs and tests and reagents. So this is part of it, is that the measures that we take cause large differences in the future. This is also tricky because if we do everything we can to prevent the spread of this virus, it should seem less of a problem, precisely because of what we're doing. And so it could be very tempting to say, well, it doesn't seem to be as bad. Let's all go back to what we were doing. And if the epidemiologists at the CDC say that, then we should. Otherwise, we should be careful, because if we stop doing what we're doing, we're changing these R values, and we're changing the outcomes. Right? So here's a graph, and I'll show you the website we got it from in just a minute. This is total US deaths due to COVID-19. And I've done an exponential regression. So this blue curve here is an exponential, is the graph of an exponential fit to the data. It's not a perfect fit, of course, but it is a darn good one. This is the sort of stuff you get in a classroom, except this is not classroom data. This is data from the United States, deaths from COVID-19, the disease caused by the novel coronavirus. So the function you get by modeling this data gives you a 25% daily increase in deaths. So the data down here in the beginning, these were all zeros. It starts at February 15th, 0, 0, 0, 0, 0, 0, and somewhere around here, we get to 1. And then somewhere over here, I forget when, it was the day that the chancellor announced that all University of Maine system classes are going online. And then we go through spring break, and then suddenly, boom, right? And this is like 500 and something. So in the course, February 15th to, let's see, what's my date? Yeah, so February 23rd, this past Monday, there's 553 deaths in the U.S. So in the course of just about 5 or 6 weeks, we've gone from 0 to over 500. Now, based off that growth factor, 1.25, we can expect in the United States on the 24th, so I don't have the number for today, but I can expect 691 today. Wednesday's the first day of classes, 864. Thursday is the day after the first day of classes, 1,000. April 3rd, 6,000. April 10th, 30,000. Let's hope it's not that much. But the fear is that the epidemiologists, the folks that study this mathematically, see this pattern. They see this data fitting an exponential curve really well. And they understand the consequences of that. The consequences are that from March 11th, which was that Wednesday that we got the announcement, to the middle of April, we might go from 38 deaths to 30,000 deaths. That's exponential growth. And if you wait until that happens, it's hard to get it under control. So, the tricky thing is, in order to slow this down, it seems like we have to jump the gun. We're closing colleges, we're closing restaurants, we're putting curfews on towns, when the numbers aren't as bad as other illnesses. Why are we doing this? Because it's really contagious. And if we don't do it, it'll get out of hand and we'll be like Italy. Italy is completely locked down and they have hundreds and hundreds and hundreds of new deaths, 400 or 500 new deaths every day. And they haven't peaked yet. So it's going to continue to get worse there for a while longer, even with extremely strict measures. The goal is to slow that down sooner than later. Now, it's very easy if you're a young person, I'm relatively young, even at 41, to say, this isn't my problem. The mortality rate for my age group is quite low. As a 41-year-old with no pre-existing conditions, it's somewhere around 0.1% or something, or 0.4%. It's very small. It's very unlikely. And most people won't be infected anyway, so I'm just not too worried about it. However, part of the reason we're doing this is because this is so infectious and it spreads so quickly, it can overwhelm what hospitals and doctors can deliver. And as it overwhelms those hospitals, doctors and nurses and orderlies, they will get sick. So staff will decrease. The things like surgical masks, swabs, respirators, ventilators, reagents for the test, those will be in short supply. As you start crowding hospitals with these patients, it will affect other people at hospitals. If you're there for some other treatment, some other sort of infection, something unrelated to coronavirus, that hospitals now has less staff, has a higher degree of infection than it did before. So, and it's also worth remembering that this is not an old person's disease, though the mortality rate is higher for older folk. It's also higher for younger folk with respiratory diseases, autoimmune disorders, diabetes. So folks your age, your parents who have asthma or are in chemotherapy or something like this, they're at a higher risk as well. So what we're doing here is we're trying to prevent a lot of unnecessary deaths and complications from overwhelming the medical infrastructure. That being said, I go back and forth day to day with optimism and panic. So if you're feeling that, I hear you. My kids can't have play dates right now. They're bored out of their minds. They're 5 and 6. It's certainly really stressful. One more thing, I'm going to show you a website that we're going to be visiting more. And it's Worldometers. It's really convenient because they gather all the data there. So here we are, and they have a United States page as well. There's the graph, where the data from. Again, look at that curve. This is not linear curve. What's the next point, right? Well, it's going to be easily about 100 more. We're going to start jumping. The jumps, look at those jumps. The jumps are going to be larger. Right? Active cases, also exponential. Daily new cases, exponential. Total cases, exponential. So all these graphs have the same characteristic that they had before, right? Oh, there we go, right? So I made those slides last night. Now you have roughly about 100 more deaths, which is about a quarter of the 500. So we're continuing with that exponential growth here. Alright, so that's all I'm going to do for this week. So it'll end up being about 20 or 25 minutes of video. I'll have some questions to answer.
quiz on Friday. That'll be it.
Okay? Best of luck. Stay safe. If you have any questions, let me know.